Okay, assalamu alaikum everyone. I hope you're all well. Let's begin. This is IGCSE O-Level Art Maths. We are doing difficult questions
Assalamu
from.
alaikum everyone. I hope you all
Okay, I'm
well.
sorry. There's going to be echo here. Just give me a second. Okay, this was muted. Walaikum assalam, Azim. I'm good. I'm doing well, alhamdulillah. I hope the echo is gone now. All right. So this is IGCSE O-Level Art Maths. We're doing June 2025 papers, difficult questions from these three papers. June 25, paper 2-1, paper 2-2, and paper 2-3. Okay, we'll do difficult questions from these papers. These are free advanced past paper sessions that I'm conducting. If you want to join, you can have a look at the link in the description. You just have to fill out that form and it will be added to the WhatsApp group. You'll also find some other helpful content in the description below, like revision videos and other videos that solve difficult questions from a number of different recent AdMath past papers. Now, today we're doing difficult questions from these three papers. June 25. Tomorrow and the day after tomorrow, I will be holding general Q&A sessions, inshallah, Sunday and Monday, in which you can bring any questions that you might have from any other papers, and we will solve them live, inshallah. Okay, that's the plan. Let's begin now. Let's begin with this paper, June 25, paper 2-1. I posted a few polls in the WhatsApp group. If you have not responded to the polls yet, please do that right now so that we can decide which questions we are going to solve from these three papers. Okay, so I'm going to start with this first paper, which is June 25, paper 2-1. So from this paper, first of all, we've got question number 7. Let me copy that and we will begin with that, inshallah. Question number 7. Okay, so there are a couple of you there are a few of you who asked about question number 6 as well. That does not look very difficult, वैसे. Okay, let's start with 7. Let's start with 7 and then we will do some more after that. I'm going to copy this question. We begin then. All right, question number 7. We're starting with this one. It's this button of Ask AI. Try to get rid of that. Okay, question number 7, part A. Let's start with this. So it says the function f is defined by f of x equals 2e raised to power minus x plus 3, where x is a real number. On these axes, what you need to do is you need to sketch the graph of y equals f of x, and hence on the same axes, sketch the graph of y equals f inverse of x as well. The positions of any points where the graphs meet the coordinate axes, they need to be shown, and also the positions of any asymptotes, they also need to be shown on our graph. Okay? Walaikum assalam. Walaikum assalam. Chale. Let's do this. F of x equals 2 e raised to power minus x plus 3. How do we sketch this graph? Now, for exponential functions, remember what the asymptote is. The asymptote of exponential functions is this constant that is added outside. So for this particular graph, f of x, the asymptote is going to be y equals 3 line. This is the asymptote. It's a horizontal asymptote. Exponential functions have horizontal asymptotes. ठीक है. Can you make a playlist covering all the O-level topics? I do plan to do that for the next year. I suppose that's what you're talking about. For the next May June session, I do want to complete the O-level syllabus, inshallah, for the next May, June, inshallah. For now, you can find complete A-level content on my channel, but you will find O-level content, more O-level content in the coming year as well, inshallah. ठीक है, अच्छा. Let me draw that line first of all. Y equals 3 line. Let's suppose it's here. Let's label this. This is the asymptote of this graph. Now, all we have to do is draw the exponential graph shape. Keeping in mind this is the asymptote, also find the x and y intercepts before that. Remember the standard exponential graph shape? What does that look like? It looks like this, right? This is the standard exponential shape. Now that's the shape when you have e raised to power x. Some constant raised to power x. This is the shape that you get for that. Now, is there any transformation, any reflection that is happening here? X is being multiplied by -1. X is being multiplied by -1. What that means is it's a horizontal reflection. So this graph is going to be reflected in y-axis. So the shape is not going to be this. The shape is going to look like this instead. So you just have to draw the shape now, something like this, right? The graph reflected in a vertical line like this. This is the shape that you've got to draw. Keep that in mind. Now, find the x or y intercepts of this graph. The x-intercept does not exist. You can try that. You can try putting y equal to 0. What do you get from that? 0 equal to 2 e raised to power minus x plus 3. You don't get any solution from this. Okay, so the x-intercept does not exist for this. It does not intersect the x-axis. What about the y-intercept? For the y-intercept, you can say 2 e raised to power 0 plus 3. That will be 2 plus 3, which is 5. So the y-intercept of this graph, that is going to be at 5. If I mark 5 here somewhere, now I know what the shape is going to be like because this is an asymptote, right? At y equals 3. So this is the shape that I have to draw. It'll look like this. The graph is going to come down here and then become almost horizontal at the line y equals 3. That's the graph of f of x. Okay, that's the exponential graph that we had to sketch. Now they also want us to sketch the inverse function. Now remember, whenever we have to draw the graph of a function and its inverse on the same axis, we always also draw the y equal to x line, y equal to x line. Now, how do you do that? You can mark this point 3 on the x-axis as well, keeping in mind to use the same scale on both axes. So whatever is the distance on the vertical axis that you're representing as 3 units, it should be the same distance on the horizontal axis that you're representing as 3 units. Similarly, mark point 5 here as well. Draw the line y equals x. It must pass through this point 3, 3 and also the point 5, 5. It would look something like this. Let's draw this line, y equals x. Now for the inverse graph, we don't actually have to find an expression for the inverse. All we have to do is just reflect this original graph in the y equals x line. Just reflect this graph. Okay, now how do we reflect this? Just interchange the coordinates. So for the exponential function, for example, we know there is a point at 0, 5. That's the y-intercept of this graph. For the log function, the x-intercept is going to be at 5. So you'll have a point at 5, 0 for the inverse function, which is the log function. For the log function, for the inverse function, you would have a point here at 5 on the x-axis. Acha, what about the asymptote of this graph? For the exponential function, the asymptote is y equal to 3. For the inverse, it is going to be x equal to 3. So what happens in this case is the asymptote is going to look like this. A vertical line at x equal to 3, that's going to be the asymptote of the inverse function. Okay, you have to draw that. This is the line x equals 3. Now, how do we draw that graph now? Just reflected in the line y equals x, You know it is going to pass through this point 5 as well. So what is it going to look like now? This part of the graph that will go here when reflected. So it's going to look something like this. The point of intersection, remember, for a graph and its inverse is always on the line y equals x. So this point that you see here, let me mark that in black here or encircle that as well. This is the point of intersection of the inverse graph and the original function. Your graph must pass through this point and then become an asymptote like this. It'll pass through the point 5 and then it'll go in this direction like this. That's the graph of the inverse function. The green graph, that's the graph for the inverse function. You label that and that's your final result. Does that make sense to everyone? Any issues with this? Is this all right? Okay. So this is what we had to do in the first part A. Let's look at the next part now. Okay, I did not copy that here. Let me copy that from here as well. Part B. All right. Part B, let's do this. Now they're saying the function g is defined by g of x equal to this, given that g inverse exists. Anyway, we know that they will intersect. When you draw the original graph, if it is intersecting with the line y equal to x, if the original graph is intersecting with the line y equals x, then whatever point it is intersecting at with the line y equals x, it will also intersect at that same point with the inverse function. Okay. So if it is passing through the line y equals x, then it must intersect the inverse function as well, because the original graph and the inverse graph, they will both pass through that one particular point. Okay. So if any point of intersection exists, it will always be on the line y equals x. Acha, what about this now? Part B. Now they're saying the function g is defined by g of x equal to 2 minus 3 over e power x plus 2, given that g inverse exists. Find an expression for g inverse and state its domain. Okay, let's find an expression for g inverse. First of all, the function g of x is 2 minus 3 over e raised to power x plus 2. That's the function. What you do is you say let y equals g of x. That becomes 2 minus 3 over e raised to power x plus 2. Now we need to make x the subject, right? Now, how do you make x the subject? You could take LCM maybe first of all, and then you take it to the other side, or let me do it this way. I'm taking this term to the left side, 3 over e raised to the power x plus 2. And on the other side, I would then have 2 minus y. Okay, this is what I have on the other side. Now, what I can do is I can actually just take, I can take reciprocal on both sides. I think that will be a good idea. So one idea is that you multiply this on the other side, then you try to isolate the x terms and then make that the subject. That is one idea that should work. You can do it that way. I'm just trying to do it slightly more efficiently. What I'm saying is, since I want to make x the subject, let's just take reciprocal on both sides. Or you can say cross multiply on both sides. That might actually be easier for you to understand. I'm cross multiplying in the sense that I'm bringing 2 minus y to this side. So it becomes 3 over 2 minus y. And now take 2 to the other side, and that will become e raised to power x equal to 3 over 2 minus y minus 2. Now, since we want to make x the subject, x needs to be brought down. Take log on both sides. You can say ln of e raised to power x, that equals ln of 3 over 2 minus y minus 2. And now x comes down there, ln e is just 1. So x equals ln of 3 over 2 minus y minus 2. And now you can write this down in inverse format. You would say g inverse of x, therefore, that is equal to ln of 3 over 2 minus x minus 2. And that's our final answer. This is what we were looking for. That's an expression for g inverse of x. ठीक है. अच्छा, now that we've got this, they're also asking for the domain of G inverse. How do you find domain of G inverse? Domain of an inverse function. Domain of an inverse function is the same as the range of the original function. So if we can find the range of the original function somehow, that'll be the domain of the inverse function. Now, can we find the range of the original function? Let's think about it. This was the original function. The domain for this original function was x greater than or equal to 0. Okay, now how do we think about this? This is a one-to-one function. How do I know that? Because e raised to power x plus 2, that is 1 to 1. E power x plus 2 is 1 to 1. When I take reciprocal of that, so 3 over that, that will also be 1 to 1, and then I'm just doing 2 minus that. So it's a one-to-one function. If it's a one-to-one function, all we care about is the endpoints. See what happens at 0. So the domain of the function is x greater than or equal to 0. What you can do is you can say x is going from 0 to infinity, right? That's the interval that we've got for x. X is going from 0 to infinity. What you do is you try the value of x as 0 first of all, and then you see what happens if x becomes extremely large. That means it goes towards infinity. See what you get from both of them. So let's input x equal to 0. G of 0. What happens at that value? So when x is equal to 0, what happens to g of x at that point? It becomes 2 minus 3 over e raised to power 0 plus 2. You do not necessarily have to show this working. You can do this directly on a calculator, and that's okay. Now, when I input x equal to 0, that's giving me 2 minus 3 over 3, which is 1. So when x is equal to 0, the y value is turning out to be 1. Okay? Acha, what if I input x as a very large number? So if x goes towards infinity, if x becomes extremely large, what happens to y in that case? If x becomes extremely large, think about it. You've got 2 minus 3 over e raised to power infinity plus 2. So in the denominator, you have an extremely large number. Constant over an extremely large number. What is that fraction going to be? You have a constant in the numerator. In the denominator, you have a very big number. This fraction is going to approach 0. So you're just left with 2 minus 0, and the value of g of x is approximately going to be equal to 2, because this is going to be extremely small, yes, but it's not going to be exactly 0. It's going to be something close to 0. So we say 2 minus 0, that gives us a value that is approximately 2. Okay? So one endpoint that we're getting here is 1 for the y value, and the other endpoint that we're getting is 2. So what's the range going to be then? What's the range going to be for this function g? Let me write that down here now. Range of the function g. It's going to be between these two values, between 1 and 2. So y is going to be between 1 and 2. In the domain, there was an equal to sign with 0. So the corresponding y value, that is also going to have an equal to sign. We are not getting exact 2. We're saying the value will get approximately equal to 2. So we are not going to put an equal to sign with 2 for that reason. So we'll say the range of this function is y between 1 and 2, where 1 is included in the range and 2 is not included. Now that's the range of G. If that's the range of G, we can say that is going to be the domain of the inverse function as well. It's going to be between 1 and 2. The only difference is, since it's domain, we write x there. We say the domain of this function, the inverse function, that is from 1 to 2, where 1 is included and 2 is not included. And that's your final answer. So you found the inverse function, an expression for that, and also the domain for that inverse function, which is the same thing as the range of the original function. So no, it's not all real values. It is between 1 and 2. How can it be all real values? It's between 1 and 2, right? Is that okay? What will be the threshold for an A? We can't say anything about that. It depends on the difficulty level of the paper and how well this cohort performs. It's decided after the paper. Nobody can tell what will happen, what will be the threshold before the paper. So we can't say anything about it. Okay, that was question number 7 from this paper. Question number 7. This was one question that you asked about from this paper. Let's move on to the next one now. Okay, next paper. Next question. Acha. The next question from this paper is question number 8 and 9. Okay, 8 and 9. Let's do these two questions from this paper as well. Questions 8 and 9. Let me copy them. Question number 8 and 9. Okay, 8 doesn't look that complicated. So let me just copy this. Question number 8. And also 9. This is the second part. Okay, maybe the second part is what is confusing you. All right, let's do this now. Question number 8 from this paper. It says solve this equation for x between 0 and pi over 2. X between 0 and pi over 2, what does that mean? X is an acute angle. X is an acute angle. Okay, it's in the first quadrant. We have to find the possible values of x given this equation. Now, how can we do that? It's already factorized, right? 2 minus 3 cot x into cos x is equal to 0. We've got 0 on the other side. So we could say either 2 minus 3 cot x is equal to 0 or cos of x is equal to 0. We get these two equations from this. Okay. Now from the first equation, we get cot x equal to 2 over 3. Take reciprocal and that will give you tan x equals 2 over 3. Just solve these two equations now. Tan x equals 2 over 3. Tan is positive. We are in the first quadrant, so we are just looking for the basic angle. Whatever is the basic angle, that will be the value for x. If you find the basic angle from your calculator, it's supposed to be in radians, right? Make sure calculator is in radian mode for this. Tan inverse of 2 over 3, that gives me 0.58800. Okay. What's the value of x? It's in the first quadrant. So the value for x is going to be the same, 0.588 to 3 significant figures. This is one possible value of x that we're getting. ठीक है. Isn't that 2 over 3? That's that. Yeah. That's not 3 over 2. That's 2 over 3, right? Achha, I did not take reciprocal. I'm sorry about that. Yeah. Okay. I took reciprocal, but I did not actually do that here. Okay, let me correct that. Achha. When we take reciprocal on both sides, on the left side, we have tan x. On the right side, it becomes 3 over 2. On the right side becomes 3 over 2. Now, since we are in the first quadrant, tan is positive. We just have to write down a value in the first quadrant. We just have to write down a value in the first quadrant. We can say tan alpha equals 3 over 2. What's the basic angle? Let me do that again. Tan inverse of 3 over 2, which is 1.5. That's 0.98279. It's in the first quadrant, so the value for x, two three significant figures, that will be 0.983, and that's our final answer. Okay, that's the first solution that we get. What about the other equation? It's cos x equal to 0. When is cos x equal to 0? You can think of it from the graph directly as well, right? Think of the graph of cos between 0 and pi over 2. Does it become 0 at any point? This is what the graph looks like. It's 0 right here. This is the point pi over 2. So you can write down the answer directly for this. Pi over 2, that does fall in the interval that is given. So you get two solutions. One is 0.983 and the other one is pi over 2. Okay, that's your final answer. Thinker, I don't teach further maths for now, unfortunately. I might start teaching that soon, but not right now. No. Okay, acha. This was part A. Let's look at part B now. Part B says solve this equation where theta is in radians and it's between -1 and 2. Okay, so now we've got an angle that is 2 theta plus 1 here, 2 theta plus 1 here. We can use a substitution for this, right? To make things easier, we can say let some other letter, maybe a, that equals 2 theta plus 1. So the equation simplifies to 2 cosecant a minus 12 sine a equal to 5. ठीक है. अच्छा, what about this now? Theta is between -1 and 2. We have to adjust the interval as well. Now, what's the interval for a going to be? You input -1 in this. What does that give you? 2 into -1 plus 1, that's -2 plus 1, which is -1. So a is going to be between -1 and input 2 in that. 2 into 2 plus 1, that becomes 5. So the interval for a that we have is from -1 to 5. Now you need to solve this equation for interval -1 to 5. Let's do that. We have to convert it to a single function. Cosecant is reciprocal of sine, right? Cosecant is reciprocal of sine, so it becomes 2 over sine A minus 12 sine A equal to 5. Multiply the whole equation by sine A, and that gives you 2 minus 12 sine square A equal to 5 sine A. Take all terms to one side, I can take them to the right, and that will give me 12 sine square A plus 5 sine A minus 2 equal to 0. That's a quadratic equation. We just have to solve this quadratic equation now. What can we do for this? We can use a substitution if we want, can do it without substitution as well. It's a disguised quadratic, right? Or in fact, just a simple quadratic. Can we factorize this? 12 times 2 is 24, 24, 8 and 3. 8 and 3 will work. Yeah, 8 and 3 will work. You can do it directly or without or with substitution. That's your choice. If I do it directly, it'll be 12 sine square A plus 8 sine A minus 3 sine A minus 2. Now, from the first two terms, I can take 4 sine A common. That leaves me with 2 sine A, no, 3 sine A plus 2. From the next two terms, I can take minus 1 common. That leaves me with 3 sine A plus 2 as well. So we get two factors from this. One factor is 4 sine A minus 1, and the other factor is 3 sine A plus 2. That equals 0. We get two factors. Now that means either 4 sine A minus 1 is equal to 0 or 3 sine A plus 2 is equal to 0. If this is confusing you, by the way, you could just write s in place of sine. So you could write this quadratic like this: 12s squared plus 5s minus 2 equal to 0. And then solve it. You'll get s equal to something, s equal to another thing, and then you replace that with sine A at the end. Okay, so if the whole thing is confusing, you can just simplify the equation like that. Okay. So now from this, I'm getting sine A equal to 1 over 4 or sine A is equal to -2 over 3. These are two equations that I end up getting from this. Sine A equals 1 over 4 or it equals negative 2 over 3. Acha, what do we do now? We have this interval given from negative 1 to 5. We can find the basic angle for each of them now. Let's find the basic angle for the first one. Sine alpha equals 1 over 4. What's the base angle or the basic angle that we get from this? Make sure your calculator is in radian mode. Let's do sine inverse of 1 over 4, which is 0.25. And that gives me 0.25268, or you can say 27. That's the basic angle. Now, sine is positive. If sine is positive, that means we can be in the first quadrant or the second quadrant. Write down all the possible angles in these two quadrants that fall in that interval from negative 1 to 5. Achha. Now, first of all, I'm getting this angle. That will be A equal to 0.2527. And then in the second quadrant, this will be another angle. That will be pi minus 0.2527. Okay, these are two possible values of A that I'm getting from this. Now, if I go from the negative side, this will be outside the interval. Remember, what's the interval for A? The interval for A is from negative 1 to 5. So from the negative side, it is going to be outside the interval. From the positive side as well, if I complete one full circle and come back here again, that will be greater than 2 pi. 2 pi is bigger than 5, so that will also be outside the interval. Okay? So these are the only possible values of A that I'm getting from this. Put that substitution back. A is 2 theta plus 1. So 2 theta plus 1 equals 0.2527, or 2 theta plus 1 equals pi minus 0.2527. And this will give you two possible values of theta. You can see what they turn out to be. Okay, you can do this calculation. Uh, I will be doing more streams tomorrow and the day after tomorrow as well. Yes, I will be doing that. It'll mostly be Q&A sessions now, tomorrow and the day after tomorrow. You'll get two values of theta from here. I'll do the calculations later on. Let's find the basic angle from the other one as well. Sine alpha equals 2 over 3. Let's see what the basic angle turns out to be from this. Okay, sine inverse of 2 over 3 now. Okay, now this gives me a basic angle of 0.72973. Which quadrants can we be in now? We can be in the third or fourth quadrants. Why? Because it's negative, sine is negative. That's third or fourth quadrants. So it's either here or here. Acha. Now we have to write down all the solutions in that given interval. Let's see what answers we get in the positive direction first of all. Let's look at the positive side first. Okay, in the positive direction, I could say, let's go here like this. That angle will be A equal to pi plus 0.72973. Pi is 3.14 something, right? So this value is going to be less than 5, which is okay. If you go further to this angle, this will be 2 pi minus 0.72973. You can check that that number is going to be greater than 5. This number is going to be greater than 5. So that is not going to be acceptable. That's not going to be acceptable. But the interval also has some negative values. The interval also has some negative values. So we also have to check in the clockwise direction if there's any other possible angle in that interval. So let's go in the clockwise direction, in this direction. This is negative 0.72973. Now, is that in the interval? Yes, it is within that interval. That is what we have for A. So this will be another possible solution that we get as well. So now we put the substitution back. 2 theta plus 1 is equal to this. Or 2 theta plus 1 is equal to this. And that will give us 4 possible solutions. Eventually, we get 4 different values of theta at the end. Let's do those calculations and figure out what those values are. And that will be our final answer. Okay. Yes, I do teach at different schools or colleges as well. I teach at, I'm from Lahore, वैसे. I teach at ISL, Trinity School, LGS 55 Main, and also City School Ravi campus. Okay, let's evaluate this. 0.2527 minus 1. Let me actually make a template for this so we can do it for all of them. Like this, 0.2527 minus 1 divided by 2. That's the first possible value of theta that I'm getting, which is negative 0.374. Negative 0.374. Okay, this is one possible value of theta to three significant figures. Now replace 0.2527 with pi minus 2.27. And that will give us another possible value, 0.944 to three significant figures. That's your second possible answer. Then do the third one. That's pi plus 0.72973, and then minus 1 divided by 2. This gives me 1.4356. That rounds off to 1.44 to three significant figures. That's another possible value of theta. And then the last one, which is negative 0.72973 minus 1 divided by 2. And that gives me negative 0.865 to three significant figures. And that's the fourth possible answer. So we get four possible answers from this. And that's your final result. That's the equation solved with four possible answers. ठीक है, कभी फैसलाबाद आए? Actually, my Nani ghar is from Faisalabad, so all my mamus, khalas, they live there. So I do come to Faisalabad quite often. My mother's side, they're all from Faisalabad. ठीक है, चलें. That's the final answer that we get. That's the final answer that we get. All right. Any questions on this? Makes sense, right? Chale, let's do question number 9. That's the next one that you guys asked about. Let's do that. Okay, cricket. I hope you don't live there. Cricket 1, 2, 3. Please don't make comments like this because I'll hide you then and then you can't comment at all. So you can delete it yourself. Otherwise, I'll delete that. Acha. Question number 9. Let's do this. Question number 9. That was part A. That's part A. I'll copy the other parts quickly as well. Okay, it has a lot of parts. Okay, one last part. Then we start with this. Okay, last question from this paper, and then we move on to the next paper after this, inshallah. Okay, last one from this paper. चलें. So it has a lot of parts. Let's begin with this. Do I take any online courses of AS? My A-level courses start by the end of August, so the registration start at the end of August. Okay. The course normally starts from 1st of September. मेरा मोटिव क्या था मैथ टीचर बनने के लिए? I really like the subject and I love teaching as well. So yeah, I'm pretty passionate about it, which you'll probably appreciate if you look at more content on my channel. Let's start with this. Question number 9. In this question, all lengths are in centimeters and all angles are in radians. Okay. The diagram shows a sector AOB of a circle. Center O, radius 15. Okay, all of that is there in the diagram. A cone, the sector is made into a cone with points A and B touching as shown. ये आपने बहुत मैथ्स के questions में भी देखा होगा, right? You have a sector, you fold that, and that makes a cone like this. Now we need to find the curved surface area of the cone. Now think about it. This is 15, the radius of the sector. When you make a cone out of this 15 becomes the slant height of this cone. Okay. Now this curved surface that you see here, that is coming from all of this region. All of this region. So when you fold it, this will be what will convert to the curved surface area of that cone. So if we can find the area of the sector, that will be the same as the curved surface area of that cone. Okay. So this is the same as the area of that sector. What's the area of sector formula? Half r squared theta. Just input values in that. Radius of the sector, that is 15. Angle theta is 6 pi over 5, and that will give you the result. You can see what that is. 225 divided by 2 multiplied by 6 divided by 5. In terms of pi, this becomes 135 pi. You can also write decimals if you want. In decimals, that will be 424 to 3 significant figures. Yeah, that's your final answer. Curved surface area of the cone is the same as the area of sector. All right, that's the first part. Fairly straightforward. Let's look at the next one now. The top of the cone is a horizontal circle. Find the circumference of the circular top. Circumference of the circular top. Okay. Now circumference of a circle is 2 pi r. The problem is we do not know the radius of the circle. Can we do anything else? When a sector is made into a cone like this, okay, can you see what part corresponds to this? Where is this coming from? When you fold this whole thing, these blue radii, they're going to come on top of each other and they're going to be joined right here. The circle on top, that is coming from this arc. That is going to come from this arc. So whatever is this arc length, that will be the circumference of that circle on top of that cone as well. Okay. So all we have to do is we can say the circumference of the circular top, that's the same thing as the arc length AB, the major arc AB, that's equal to that. Radius into angle, that will be 15 into 6 pi over 5. You can see what that is, 18 pi. And that's your final answer. That's the same thing as the circumference of the circular top. Okay. ठीक है. You can write down decimal value as well. It's not required, though 18 pi will be acceptable. If you want to write decimals, you would say this is 56.5 to three significant figures. I would recommend that you write down the exact value first, and then you can round it off to. Then you can write down the decimal value after that. Okay, let's move on to the next one. Part C. Let's look at part C now. Okay, in part C, they're saying, hence find the radius of the circular top and the perpendicular height of the cone. Let's call this height h. Let's call this radius r. When we know the circumference, that's 18 pi. How can we find the radius? We can say circumference, which is 2 pi r, that equals 18 pi. So what's the value of r that we get from that? Pi and pi get cancelled. 18 over 2, that is 9. Radius turns out to be 9. And if radius is 9, now you can think of this as a right angle triangle. R is equal to 9. Think of this triangle. You know the hypotenuse, you know one side, you can find the third side using Pythagoras. So you'll say 8 squared plus 9 squared equals 15 squared. And now since it's a Pythagorean triple, you will get 12 from that. You can check that as well, put it on a calculator. 15 squared minus 9 squared, which is 81, square root of that, that is 12. Right, the value for h, that turns out to be 12. The height of the cone, that's what they were asking about. Okay, that's our final answer. Now they're saying water is poured into the cone. Water is poured into the cone. When the depth of the water in the cone is h, the radius of the circular top of the water is r. Find an expression for r in terms of h. Okay. When the depth is h, the radius of the circular top is r. How do we think about this? We can say, let's suppose we've got water in the tank. That maybe looks like this. This is the water in the tank. Now they're saying the depth is represented by h. The depth of water is represented by h. This is h up to this point. And radius is r. Radius is r. We need to represent r in terms of h. Can we do that? It will be similar triangles, right? Or similar cones. So when we have water up to this level, for example, the cone that you're getting here and the bigger cone, these are similar figures. So the ratios of their corresponding sides, they must also be equal. So whatever is the ratio here between r and height, height is 12, right? So ratio between r and height is 12 or 9 over 12. It will be the same ratio for that smaller cone as well. So we can say r over h. Since they are similar cones, ratios of corresponding sides, they must be 9 over 12. Radius was 9 for the bigger cone. Height was 12 for the bigger cone. So it will be the same ratio here. You want r in terms of h, multiply h on the other side. Simplify this as well. This will become 3 over 4. So you have 3 over 4 times h. That is what we were looking for. That's your final answer. Okay. All right, let's move on to the next part. Water is being poured into the cone at a constant rate of 27 centimeter cube per second. Find the rate at which the depth of the water is rising when the depth of the water is 4 centimeters. Okay. So water is being poured at this rate, 27 centimeter cube per second. Now this is volume per time. So we are given the rate of change of volume, right? dV over dt. That's what we're given. dV over dt. That is equal to 27. Rate of change of volume of water. What we are looking for is the rate at which the depth of the water is rising. So we are looking for dH over dt. We need to figure out what this is. When the depth of the water, that means when H is equal to 4. At that particular point, we're looking for dH over dt. Now, how do you figure this out? This is rate of change problem, right? We use chain rule for this. dH over dt, what is this going to equal? It'll be a product of two fractions. The numerator of the first fraction is going to be dH. Denominator of the second fraction is going to be dt. And in these places, we've got the third variable, which is volume, in this case, dV. Now, dV over dt, we already know that's 27. What we do not have is dH over dV. For that, we need some connection between volume and height. Do we have that? What's the volume of a cone given by? Volume of a cone is given by 1 over 3 pi r square h. That is what volume of a cone is given by. Okay? We need to find dV over dH from this, derivative of volume with respect to height. How can we do that? We have two variables in this case, r and h. So first of all, we need to convert it to a single variable. That's the reason they made you do this in the previous part, r in terms of h. So we can use that relation and we can say volume is equal to 1 over 3 pi. In place of r, you input 3 over 4 times h whole squared, and then you have h multiplied outside. Simplify this. I'll just do this on a calculator. 1 over 3 times 3 squared, which is 9, divided by 16. That's 3 over 16. Pi, h squared and h, that becomes h cubed. So v is equal to this. That's the equation that we've got for volume and height. Now we can differentiate it and find dv over dh. What does that turn out to be? 3 over 16 times pi multiplied by the power. Subtract 1 from the power. And that becomes 9 over 16 pi times h squared. That is dv over dh. Now they wanted us to find that rate of change of depth of water at the point when h was equal to 4. So what we can do now is we can put h equal to 4 in this and see what that gives us. dv over dh. What does that turn out to be? 9 over 16 into pi into 4 squared. 16 and 16 get cancelled and we have 9 pi. That is dv over dh. Okay, once we've got this, let's input this back here in that chain rule, and that gives us dH over dt, that equals dH over dV. That will be reciprocal of this thing. That's 1 over 9 pi multiplied by dV over dt, which is 27, and that simplifies to 3 over pi. Put this on a calculator, 3 divided by pi. In decimals, that number is going to be 0.955. That's the rate of change of depth of water when the volume is increasing by 27. And that's what we were looking for. Okay? Makes sense to everyone? That was the last part of this. Let me know if there's any question. So we'll be starting our next paper, inshallah, which is May-June 2025 paper, variant 2.2. In a couple of minutes, I'll be back in a minute or two. I need to take an important call. Then we resume, inshallah. Okay, chale, let's resume. Let's look at the next paper now. Let's look at the next paper now, which is May June 2025, paper 2, variant 2. Question 9 from the last paper was the last one that you guys asked about. The next one after this now is this paper, May June 25, paper 2, variant 2. Just give me a second and see which questions you've asked about from this paper. Okay, May June 25, paper 2, variant 2. From this paper, we actually do not have many questions. Okay, so we have quite a few from the next paper, but not many from this paper. So apparently this paper was not that difficult. Okay. What I'll do is I'll go through the questions in the paper quickly. There are a couple of questions that have a few votes. Let me see if any one of them is particularly difficult or looks difficult. Might just have a quick look at that. Okay, question number 6. Volume is increasing at this rate. Okay. Question 9. Okay, so it doesn't look like a difficult paper. Most of the questions are not difficult in this. What I'll do is I'll just do a couple that have relatively more votes than the other ones. One of them is this one, question number 6. Let's start with this. Question number 6 from this paper. May June 25, paper 2, variant 2. Let's look at question number 6. It says the volume V of a sphere is increasing at the constant rate of 2 pi centimeter cube per second. Find the rate of change of the surface area of the sphere when the volume of the sphere is equal to 36 pi. Okay, now how do we think about this? Let's write down the information that's given. Volume is increasing at this rate. So dV over dt, rate of change of volume, what is that equal to? That's equal to 2 pi. dV over dt is 2 pi. What we are looking for is the rate of change of the surface area. So what we're looking for is ds over dt. What is that going to equal? It's going to be equal to product of two fractions. One is going to have ds in the numerator. The second is going to have dt as the denominator. And in these places, we would have the third variable. Whatever that third variable is, it could be volume. It could possibly be radius as well. We'll think about it. We are also given the volume number at this point. So if we can find a relation between ds over ds and dv, that will be 4 pi over 3. Let me write down the equations for volume and surface area. What is volume of a sphere given by? Volume is given by 4 over 3 pi r cube. And surface area is given by 4 pi r squared. Okay. Achha, now, there are two ways of doing this. One idea could be that you could use, in this chain rule, ds over dv into dv over dt. That could be one idea. Yeah, that will work. You can do it this way. This is one possibility. And another possibility could be then instead of using dv there, you use dr, ds over dr. So you differentiate this thing. And then you could find dr over dt first. So use chain rule twice in that case. Let's just do it the first way. I think that will probably be quicker, although slightly complicated, but it's okay. I think we can do that. Let's do it this way. Let's make the chain rule like this. ds over dt, that's what we are looking for, rate of change of the surface area. ds over dt, that equals ds over dv into dv over dt. Now, dv over dt is already given. All we have to do is figure out ds over dv. Once we've got that, we just input that in the chain rule, and that will give us the result. Okay? So how do you find ds over dv? You can find a connection between s and v, an equation that connects s and v. Now, one way to do that is that you make R the subject from any one of those two equations. If I make R the subject from the first equation, let's see what we get. I can take this whole thing to the other side, and that will give me R cube equal to 3v over 4 times pi. Okay. Now take cube root on both sides. R equals 3v over 4 pi whole raised to the power of 1 over 3. Okay, this is what R turns out to be in terms of V. Now what we do is we put that in the other equation. So we have a connection between S and V then. We have an equation that connects S and V. Let's see what we get from that. S equals 4 pi. In place of R, you input this thing, and that will become 3V over 4 pi whole raised to the power 1 over 3 squared. That becomes 2 over 3. Okay. Let's simplify this a little now. Separate out the constants. Separate out the constants. We don't want an exact answer, right? So it doesn't matter if we just do it like this. 4 pi into 3 raised to power 2 over 3. I'm writing the constant separately. 3 is a constant. So 3 power 2 over 3. And also in the denominator, I have 4 pi raised to power 2 over 3. Now, remember, this whole thing is a constant. This whole thing is a constant. What are we left with? V raised to power 2 over 3. That's the surface area in terms of volume. Okay? We found the surface area in terms of volume of the sphere. Now we can differentiate it. Let's differentiate it. I'll keep it as it is in the same form. Let's find the derivative of this, ds over dv, and see what that turns out to be. Remember, this whole thing is a constant, so that's going to remain as it is. You just multiply this with the power, multiply by 2 over 3. So it gets multiplied by 2 over 3. You get 2 over 3 times 4 pi into 3 raised to power 2 over 3 divided by 4 pi raised to power 2 over 3 into v raised to power 2 over 3 minus 1, which is negative 1 over 3. So we found the derivative. All we have to do is input that value for volume here. Input that value for volume. Volume of the sphere is 36 pi. That is the instant at which we want to figure out the rate of change of the surface area. Let's just input that value here and put this on your calculator. So input volume equal to 36 pi. And see what that gives us. 2 over 3. You should show this working in the step in which you're inputting that value here. (36 pi raised to power negative 1 over 3). Now just put this whole thing on a calculator. See what that gives you. Let me do that. Can somebody else do this as well? So we are not making any careless mistakes. We can verify that. 2 over 3 multiplied by fraction 4 pi into 3 raised to power 2 over 3. Looks okay. 4 pi raised to power 2 over 3. Look at this azan going on here. We'll have 30 seconds break and then we'll resume. All right, chale. So this is what we are getting. ds over dv, that turns out to be 2 over 3. All we have to do now is input this thing back in that chain rule and you'll get the result. Let's input it there. ds over dt, that is equal to this. Input values, ds over dv is 2 over 3 multiplied by dv over dt, which is 2 pi. And that gives you 4 pi over 3. And that's your final answer. You can put this on a calculator to simplify this. And that's giving me 4.19 to three significant figures. That's our final answer, ds over dt, rate of change of the surface area with respect to time. Okay, that's what we were looking for. Makes sense. Let's look at the next question now. This was slightly tricky because we had to form this equation first in terms of S and V and then differentiate that. There is one more question from this, I think, and then we move on to the next paper after that. Okay, question number 9, let's do this. One last question from this paper. Question 9. Okay, this is the first part. The second part is also 5 marks. Okay, so now we've got this trigonometric equation, or in fact, two trigonometric equations, and we have to solve them. Let's do this, and then we move on to the next paper after that, after namaz break. Let's do this one question before the break. We have to solve this equation 3 secant 3x equal to under root 3 cosecant 3x for x between negative 120 and positive 120. All right, how can we do this? This is secant, this is cosecant. Let's convert them to their base functions. That will make it easier to think about. 3 over cos 3x. On the other side, we have under root 3 over cosecant is reciprocal of sine, right? So that becomes sine 3x. We can cross multiply and do something like this. Sine 3x divided by cos 3x. Bring 3 from that side to the right. On the left now we've got tan. Sine over cos is tan, right? So tan 3x is equal to under root 3 over 3. This is what we're getting. Now, remember the interval that is given is for x. This is 3x. You can either use a substitution or do it without substitution, whichever method you prefer. If x is between negative 120 and positive 120, then what about 3x? 3x is going to be between negative 120 times 3, which is negative 360, and positive 120 times 3, which is positive 360. So the interval that we are going to look the values for in are is from negative 360 to positive 360. How do we find the values of x now? Find the basic angle. Tan alpha equals under root 3 over 3. What's the value of alpha? I think this is 30 degrees, right? Let's just confirm that. Make sure calculator is in degree mode now. You should always check that whenever you're working with sine, cos, tan. Tan inverse of under root 3 divided by 3. 30 degrees, that's the basic angle. Now the basic angle is 30, tan is positive. Tan positive is in the first quadrant or in the third quadrant. Those are the two quadrants that are possible. So we can either be in this first quadrant here or in the third quadrant here. Now what are the possible angles going to be? This, and then from the negative side, you could have this and also this. Right, these are four possible angles that you would think about. So 3x is either equal to just 30 in the first quadrant, or 3x is equal to 180 plus 30 in the third quadrant. Or 3x is equal to, when we go from the negative side, it's equal to 180 minus 30 with a negative sign because we're going clockwise, or 3x is equal to 360, one full circle, minus 30, and we put a negative sign with that because we're going clockwise. These are four possible answers that you would get. X is either equal to 10 or x is equal to 105 from here, or x is equal to negative 50 degrees from here. Actually, sorry, we were dividing by 3. So 210 over 3, that would be 70, right? This is minus 150 over 3, which is minus 50. And the last one, minus 330 over 3, that will be minus 110. These are four possible solutions that you would get: 10, 70, negative 50, and negative 110. And that's the final answer. That was not complicated. As long as you know how to do such problems, you have to adjust the interval. That is important. That's your final answer. ठीक है. Makes sense, right? Let's move on. Next, we've got this equation. This looks slightly more complicated now. How do we solve this equation? We can use a substitution. This is y plus pi over 3, y plus pi over 3, y plus pi over 3. To avoid writing that again and again and simplify things, let's use a substitution. Let a equals y plus pi over 3. You can do it without substitution as well, but it'll make things slightly simpler. Let's adjust the interval as well. If y is between 0 and 2 pi, then what about a? What is a going to be between? 0 plus pi over 3. You input 0 here. That becomes 0 plus pi over 3. That gives you pi over 3. Input 2 pi here in place of y. 2 pi plus pi over 3. That will be 7 pi over 3. So this is the interval for a. The values of a that you would look for eventually, they have to fall in this interval. Take it between pi over 3 and 7 pi over 3. Now let's write down that equation. That is 2 cos a into sine of a equals sine of a. Now, can I just cancel out the sine on both sides? Will that be a good idea? We should not do that, right? Because sine is an unknown. What if sine A is equal to 0? Because when it's equal to 0, if we cancel it like this, that will be like saying we are dividing by 0. And that's undefined. So what's the proper way of solving equations like these? We take all terms to one side. We say 2 cos A into sine A minus sine A, that equals 0. Now you take sine A common. That leaves you with 2 cos A minus 1 inside. So either sine A is equal to 0 or 2 cos A minus 1 is equal to 0. And this gives us cos A equal to 1 over 2. Acha, when is sine equal to 0? Within this interval, let's think about it. This is what the sine graph looks like, right? It is 0 initially at 0, then again at pi, then at 2 pi, and then again at 3 pi. 0 does not fall in that interval. The first value that does fall in that interval is pi. Okay, that's one possible answer. Another value that falls in that interval is 2 pi. 2 pi is less than 7 pi over 3 as well. So that's another possible solution. What about 3 pi? 3 pi is greater than 7 pi over 3. So the only possible solution that we get from the first one are pi and 2 pi. Okay, these are two possible values of A. Achha, now, what about this equation? We can find the basic angle first of all. Cos alpha equals 1 over 2. Put this on your calculator. You should get pi over 3 from this, right? Cos is 1 over 2 when it's pi over 3, when the angle is pi over 3. Now, which quadrant can we be in? It's the cos is positive, right? So we could be in the first quadrant or the fourth quadrant. Those are the two quadrants that are possible, first or fourth. So the basic angle could either be here or the basic angle could be here. These are two possibilities. Now the interval is from pi over 3 to 7 pi over 3. The basic angle that we're getting is pi over 3. Let's write that down here. We have an equal to sign with pi over 3 and do not have an equal to sign with 7 pi over 3. So now when we go in the positive direction, this is the first angle that we get. This does fall in that interval because we have an equal to sign. So one possible value of A that I'm getting from this is pi over 3. Let's go further. This will be another one. What's that? 2 pi minus pi over 3. And then if you complete one full circle and come back to this point again, that will be 7 pi over 3. And you see there's no equal to sign with 7 pi over 3. So we would not consider that as a possible answer. These are two possible values of A that I'm getting. Now put that substitution back. Substitution was y plus pi over 3. So what we're getting is y plus pi over 3, that is equal to pi, or y plus pi over 3 is equal to 2 pi. The first one gives me 2 pi over 3. That's one possible answer. The second one gives me 2 pi minus pi over 3. That will be 5 pi over 3. That's another possible solution. Then put the substitution here. Y plus pi over 3, that equals pi over 3. You get y equal to 0 from this. That's another solution. And then the last one, y plus pi over 3, that is equal to 2 pi minus pi over 3. That will become y equal to 2 pi minus 2 pi over 3, which is going to be 6 pi minus 2 pi, 4 pi over 3. This is another possible solution that we're getting. So the final values of y that we get, they are 2 pi over 3, 5 pi over 3, 0, and 4 pi over 3. And that's what we were looking for. These are our final answers. Make sense? Okay, I hope that helps. We are going to have a short break now. We're gonna have a short break. We resume at 7:30, inshallah. Okay, we'll resume in about 15 minutes, inshallah. Okay, everyone, let's resume. I'm sorry for the delay. Let's resume. Okay. So we're done with this paper. We're done with this paper. May, June 2025, paper 2-2. Now we're doing paper 2-3 after this. And this is the last paper that we're doing today. Let's look at the difficult questions from this paper as well. Okay, so I've got the poll open in front of me. Let me see which questions you've asked about from this paper now. Okay, so from this paper, we have question number 4. Okay, let me copy that here. Question number 4. Sure, let's start with this. Okay, so there are like 4 or 5 questions from this paper that you've asked about. Let's do all of them. Question number 4, this is part A. Okay, part B. Okay, there's another one as well. Part C. Okay, so let's start with this one. Question number 4 from this paper, it has these 3 parts. Let's start. The function f is defined by f of x equals 2x minus 1. Explain why the function f square cannot be formed. Explain why f square cannot be formed. How do we think about this? When can a composite function be formed? When the range of the inner function is within the domain of the outer function. That is when a composite function can be formed. Now, what's the range of this function? If the domain is all real values, then it's a linear function. The range is also all real values. Range of f is also all real values. It's a linear function. If the domain is all real values, then range is also all real values. So why can f square be formed? In this case, f is the inner function, f is also the outer function, right? In f squared, we can say the reason for that is the range of f is a subset of the domain of f. Now, in this case, in fact, they're actually equal to each other. So subset can mean equal as well, right? That is possible if it's an improper subset. So, but that's the general explanation that we've got. In this case, you can also say, since they're both all real values, you could also say range of f is actually the same as the domain of f. So for this particular question, you could also write this explanation, and that will also be fine. In general, the condition is the range of the inner function has to be within the domain of the outer function. That is when a composite function can be formed. Okay. So what about the second one now? They're saying sketch the graph of f square of x, modulus of that, state any intercepts with the coordinate axes. What we can do first is we can find that function f square of x and see what that is. F of x, that is equal to 2x minus 1. So what about f square of x? What is that going to be? Inside the function f, we have to input f. So 2 into 2x minus 1, and that simplifies to 4x minus 2 minus 1, which is 4x minus 3. That's f square of x. Now, if you want modulus of that, if you want modulus of that, you have modulus of 4x minus 3. You have to sketch this graph. How do you sketch the graph of a modulus function? When it's a linear function, all you have to do is just find the vertex. Find the vertex of this. Where is the vertex of a linear function in modulus? When this thing inside is equal to 0, 4x minus 3 equal to 0, that's where the vertex is going to be. That's also the y-intercept of the graph, x equals 3 over 4. You have the x-intercept of the graph. The x-intercept is here, let's say, this is 3 over 4. Find the y-intercept. How do you find that? You put x equal to 0. When you put x equal to 0, the y value that you get from this function is minus 3 modulus, which is going to be 3. So mark that point 3 on the diagram. Let's suppose that's here. Now, since it's a linear function inside modulus, you'll get a V-shaped graph like. So from the vertex, make a line here, and then make a symmetrical line on the other side, such that this is the line of symmetry. And this is what the other graph is going, the other part is going to be. So you have a V-shaped graph like this, and that's what we had to draw. Okay, that was easy, 4 marks. This is all that you had to do. The alternative of doing this is that you do with any modulus function in general. You draw that linear function, first of all, 4x minus 3, and then the part that is below the x-axis, you reflect that and take that above the x-axis. That's also okay. That will also work. Okay, that's this question. Is that all that they asked about in this part? Sketch the graph of this, state any intercepts. Yeah, so this is all that you had to do. That was part B, easy 4 marks. Okay, now they're saying it's given that modulus of f square of x that is less than or equal to ax plus b. Okay. For x between minus 1 and plus 3. And for no other values of x. Okay. So this modulus function is less than some other linear function. Ax plus b is a linear function. For these values of x such that x is between negative 1 and 3. Now, they have made you sketch the graph of the modulus function in the previous part. Can we use the graph somehow? So we might have a negative 1 on the left side somewhere. Let's suppose that's here. And then 3 on the right somewhere. Let's suppose that is around here, maybe. Let's suppose this is 3. Let me just extend this line a little as well, so we can understand this better. So they're saying for this interval from minus 1 to 3, this modulus graph that we have drawn is below another line, is below this ax plus b line. Now, where would that line be? Let's find these points on the graph first of all. What are the y values corresponding to these points? Let's figure them out. So on the f square of x graph, let me actually first, this is the modulus graph, right? The modulus function is 4x minus 3 modulus. Let's first of all figure out the y values at this point. When x is equal to negative 1, what's the y value that we get from that? 4 into minus 1 minus 3, which is minus 7. Modulus of that is plus 7. So x equals minus 1 gives us y equal to 7. And when x is equal to 3, the other endpoint, what's the y value that we get at that? 4 into 3 minus 3 modulus of that. That will be 12 minus 3, which is y equal to 9. Okay, so what we get from that is when x is minus 1, there's a point on this graph where x is equal to, where y is equal to 7. So we have this point minus 1 and 7. And when x is equal to 3, there's another point on the graph that is at 3 and 9. Between these 2 points, there's a line that is above this modulus graph. So that line could look like this, right? This line. This line is above the modulus graph between x equal to -1 and x equal to 3. It's between these two. It's above the modulus graph between these 2 points. They mentioned for no other values of x should this line be greater than that. What that means is we can't say that the line is above here somewhere. That is not possible because in that case, there will be some other values of x as well on the left side and on the right side for which that condition is satisfied. The condition should only be satisfied for values of x from -1 to 3. For that, it's necessary that the line passes through these 2 points. Now, can we find the equation of this line somehow? We know 2 points on the line, we can find the gradient, we can write down the equation, and that's what we're looking for. Let's do that. We've got the 2 points. We've got the 2 points. One point is -1, 7, and another point is 3 and 9. These are 2 points that we've got. All we have to do is find the gradient of this line. That is 9 minus 7. Divide that by 3 minus -1. And that's 2 over 4, which is 1 over 2. That's the gradient that we're getting for this line ax plus b. Now, once we've got the gradient, we can write down the equation of the line because we've got 2 points, -1, 7, 3, 9. Use any one of those 2 points. Along with this gradient, you can say y minus y1, y minus, I'm using this point, y minus 9 equals 1 over 2 into x minus 3. That's the equation. Let's convert it to this form, ax plus b, as in y equals mx plus c. Let's take everything else to the right side. It becomes half x minus 3 over 2 plus 9. What do we get from this? Half x plus 9 minus 1.5, that will be 15 over 2. They wanted us to find the values of a and b. What are the values of a and b going to be now? Let's compare with ax plus b form. We can say the value for a is 1 over 2 and the value for b is negative 15 over 2. And that's our final answer. These are the values of a and b for which the straight line would be above that modulus graph. So it has to intersect the modulus graph at those 2 points that we found earlier. So a is equal to 1 over 2, b is equal to negative 15 over 2. And that's our final answer. This is what we wanted to figure out. Is that okay to everyone? Any issues with this? Okay, I'm sorry, b is plus 5 over 15 over 2. Yes, b is plus 15 over 2. This is plus 15 over 2. Yeah, I wrote minus for some reason there. 9 minus 3 over 2 is 15 over 2, right? So b turns out to be plus 15 over 2, yes. All right, ठीक है. Okay, chale, let's look at the next one now. That was part C. Let's look at the next question. That's it for on this question. Let me look at the next one now. Next one from this paper is question number 6. Let's do that. Question number 6 from this paper. ये देखते हैं. I'll copy that here. Okay, that's a permutation and combination question now. These are 2 parts. There's another as well. Does it look very difficult, Vesa? Okay, let's do this. Question number 6 from this paper. That's the next one. Question 6. Let's try this now. So they're saying 5 of the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 They're used to make a 5-digit number. Find how many ways this can be done when the 5-digit number is greater than 50,000. Remember, when we're making digits, when we're making numbers, the order always matters, right? Because if you change the order of digits, it'll be a different number. So it's permutation. It's not combination, it's permutation. How do we think about this? The number has to be greater than 50,000. The 5-digit number, so it has to be a 5-digit number. What we can do is we can make 5 boxes for this. We want to make a 5-digit number. Let's make 5 places for those 5 digits. 1, 2, 3, 4, 5. Now, since the number is greater than 50,000, we have a condition on the first box that the first box needs to have a number that is either equal to 5 or greater than 5, right? So what are the possible numbers that you can input in the first box? 5, 6, 7, 8, 9. There are 5 possibilities for the first box. You can fill the first box in 5 different ways. You could input 5, 6, 7, 8, 9. So there are 5 ways of filling the first box. Now, if there's 5 ways of filling the first box, what about the rest of the boxes now? For the next box now, how many places do we have? There are 8 digits left. So we have 8 options for the next one, and then 7 for the next one, 6 for the next one, 5 for the next one. Multiply all of these numbers, and that's going to give you the result. An alternative could be, you could say 5 options for the first box, and then out of the remaining 8 digits that you would have, arrange 4 here. So you could also say that's 8p4. So this thing, 8 into 7 into 6 into 5, that's the same thing as 5p4. And that will give you the result. You can see what that is. 5 into 8 into 7 into 6 into 4. 6 into 5, sorry. And that gives me 8,400. And that's our final answer. That's the first part. Again, that was fairly straightforward, easy arrangement problem. Let's look at the next one now. Now they're saying, in a group of 13 people, 7 have red hair and 6 have brown hair. The 13 people stand in a line for a photograph. No person with red hair is standing next to another person with red hair. Find the number of different ways this can be done. Okay, so all the people having red hair, they need to be separated. That's a standard case of dashes and stars method. You can use that. Although in this case, it's actually even simpler because there are 6 people who have brown hair and red hair people have to be separated. And there are 7 in numbers. So that actually tells us they have to stand alternately like this. There's no other possibility. So they will be standing like this. R, B. Now there are different people, right? People can never be identical. So we can say R1, B1, R2, B2. So they're standing like this, alternately. There's no other possibility. They have to stand alternately because there's 7 with red hair, 1 less with brown hair. If you want to separate all the red ones, this is the only possible arrangement that you can have. Okay, so you have R, 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 R. There are 7 R's. Okay. There are 7 R's that we've got. And then we have 6 blues. Okay, 7 R's and 6 blues. This is what we've got. And how many ways can we arrange them? The 7 R's, there are 7 places for them. That will be 7 factorial. And the 6 blues, there are 6 places for them. That will be 6 factorial. 7 factorial into 6 factorial, because there's no other possible positioning that they can have. If all people with red hair have to be separated, this is the only possibility that you've got. Okay, they have to be alternately like this. Okay? 7 factorial into 6 factorial. That will give us the result. You can see what that is. Let's just input this on a calculator. 7 factorial. Where is that? 7 factorial. Yeah. Into 6 factorial. And that gives me 3628800. That's our final answer. This is what we were looking for. ठीक है. Insha or Inshal, you can search on my channel, and in the last 2, 3 videos, the most recent videos, you'll find the solution for that complete paper. March 26, that's solved completely. I did that, I think, a couple of days back. You'll find the solution to the last part there as well. Okay. Yeah, that was a bit complicated. The last part, I remember what you're talking about. Have a look at that. You'll understand. Okay, Chris chooses 5 people from this group. Find the number of ways Chris can do this if at least one person chosen has brown hair. Okay, so 5 people have to be chosen from that group. Out of 13 people, we want at least one person who has brown hair. Achna, there are 2 ways of doing this. Two uh, primary ways of doing this. One idea could be you could make cases. You could say, okay, one possibility is you have one person with brown hair. So you want at least one person with brown hair, right? So you could say one, you could have 1, 4, 2, 3, 3, 2, 4, 1, or 5, 0. You could make all of these cases. For the first one, for example, you could say out of 6 brown people, we want one, and out of 7 people who have red hair, we want four. And similarly for the rest of them, add them up together. That is one possibility, and that will work. But it's only 2 marks. Is there a more efficient way of doing this? They want at least one person to have brown hair. They want at least one person to have brown hair. What if we do the opposite of this? We say, let's find the total number of possible selections if there was no condition. Subtract from that the case when there is no person with brown hair, because everything else is going to be those cases when you have at least one person with brown hair. Total minus no brown hair case. Yes, exactly. So that will be much more efficient. This will also work. You make these 5 cases, add them up together. That's a lot of working for 2 marks. You could do it more efficiently. You could say, let's find the number of possible selections with no brown haired person. What would that be? That we don't select anyone from those 6 people, 6C0, and and from the remaining 7 we select 5. 6C0 is just one, so it's not necessary that you write that. You can just write 7C5 as well, and that will give you the result for no brown-haired people, their selections. That's 21. Subtract this number from the total number of possible selections. At least one brown-haired person. What will be the number of possible selections for that? Total selections out of 13 people, select 5 if there were no restrictions. Subtract from that this 21, and that will give you the result. Let's see what this turns out to be. 13 C5, that is 1287, minus 21, and that is 1266. That is what we were looking for. ठीक है? Makes sense. That was not that difficult. Permutation combination questions in the recent papers, the ones that have come in paper 2, they have not been very difficult, Vise. Most of them have been relatively straightforward. Okay, this was question number 6. Let's do the next one now. All right, so the next one that we've got from this paper is question number 9. All right, question 9, let's do this. Question 9. Okay, let's do this. Question number 9 from this paper. Let's start with this. Okay, that's a long statement. Let's read it a bit slowly, so we don't make any careless errors. With the first term of an AP, that is 9. Okay, let's just note down that information. We have an arithmetic progression. We know the first term is 9. The last term of this progression is 159, and sum of all the terms is 2604. Okay, whatever is the last term, let's call that Tn. If the number of terms is n, that is 159. And we know that the sum of all of those terms, Sn, that is 2604. Okay. The 12th term of this AP is the first term of a geometric progression. The 8th term of this AP is the second term of the GP. Find the sum of the first 6 terms of the geometric progression. Okay, so what we can do is we can find the 8th term of this AP and the 12th term of this AP, and then use them to make this GP, and then find the sum of the 6 terms of the GP. It doesn't look very difficult. So let's start with this. So break it down. First of all, find the 12th term and the 8th term of this AP. How can we do that? The term formula for an AP is a plus n minus 1 times d. So we need the first term. The first term is already there. We need the value for n, that is also already there. The only thing that's missing is the value for d. D is missing, right? How do you find the value for d? You can use the sum that is given to us. Let's use that to figure out the value for d. Now remember, there are two sum formulas that we've got. One sum formula for an arithmetic progression, that is half n into 2a plus n minus 1 times d. And another sum formula that we've got is Sn equal to half n into a plus tn. You can use any of them. Or in this case, since you have the last term given, it will be very helpful to use the second formula to find the number of terms that we've got in the sequence. Because n, the number of terms, we don't know what that number is, because once we've got the value for n, then we can use the first formula to also find the value for d afterwards. So let's use both sum formulas. Let's use the second one first. We know sum of those n terms is 2604. So 2604, that is equal to half into n. What's the value for n that we've got? We have to figure that out. Into a, which is 9, plus the last term, the nth term, that is 159. That is going to give us the number of terms in this sequence. Let's figure that out. 2604 multiplied by 2 from the other side, divided by 9 plus 59, which is 168. And the value for n turns out to be 31. So we know there are 31 terms in the arithmetic progression. Okay. Now, once we know that there are 31 terms in the arithmetic progression and the AP, input that in the first formula. The sum of the n terms is 2604. That equals half into n. The value for n now we know is 31 into 2 times a. The value for a is 9 plus n minus 1. That means 31 minus 1 times the difference. And that is going to give you the value for d as well. Multiply 2 on the other side. 2 into 2, 2604. That gives me 5208. That equals, can I divide 31 by divide this by 31? Will that be an integer? Divided by 31. Okay, so let's simplify this. Divide 31 on the other side as well. On the right side, I'm just left with 18 plus 30 times d. And that's going to give us the value for d. You can see what that is. Minus 18 and then divided by 30. The value for d that I'm getting from this is 5. So for the arithmetic progression, now I know the value for d is 5. A we already knew was 9. So now what we can do is we can write down the 12th term of the AP and the 8th term of the AP. Let's figure out what the 12th term is going to be. Remember the term formula? The term formula is Tn equals a plus n minus 1 times t. Just input values in that. T12, that will be a, which is 9 plus 12 minus 1, which is 11 times the difference. And that will give you something. Similarly, find the eighth term of the sequence. 9 plus 8 minus 1 times the difference, which is 5. So 12th term turns out to be 9 plus 11 into 5, which is 64. And the 12th term turns out to be 64. And the 8th term turns out to be 9 plus 7 into 5. And that is 44. The 8th term of the sequence is 44. Okay. Now they told us the 12th term of the sequence is the first term of the GP and the 8th term is the second term of the GP. So now we've got a geometric progression. Now we have a geometric progression GP for which we know the first term is 64 and the second term is 44. And then this GP continues like this. What we can do now is we can figure out the ratio of this GP. A is 64. What about the ratio? Ratio would be 44 divided by 64. That's the ratio of this GP. We can simplify this. Let's see what this simplifies to. 44 over 64, that simplifies to 11 over 16. Now that's the ratio. We've got the first term and the ratio. What we're looking for is the sum of the first 6 terms of the GP. We had an AP earlier. Now we're talking about the GP, sum of the 6 terms. What would that be? S6. The sum formula for a GP, that is given by A into 1 minus R raised to power n divided by 1 minus R. Input values in that. A is 64 into 1 minus 11 over 16 whole raised to power 6 divided by 1 minus 11 over 16. You can put this whole thing on your calculator directly and get a result from that. Let's see what we get. 64 times 1 minus 11 over 16 raised to power 6. The outer bracket closed as well. In the denominator, we have 1 minus 11 over 16. And that gives me 183.174. To three significant figures, that becomes 183. That's the sum of the first 6 terms of this geometric progression. That's what we were looking for. That's our final answer. ठीक है. Any issues with this? Make sense, right? Okay, chale. Let's do the next part. So there's another part as well. There's another part as well. Now they're saying a different geometric progression. It's a different GP. It has the first term sine theta. Okay. The ratio of this progression is cos theta, where theta is between 45 and 135. Show that this progression has a sum to infinity. When does a sum to infinity exist? For a GP, when the ratio is between -1 and 1. Sum to infinity exists when ratio is between -1 and +1. Now, can we find whether the ratio is going to be between those two numbers? It's a cos function, right? What does the cos graph look like? The cos graph looks like this. This is what the cos graph looks like. This is y-axis, this is x-axis. It starts from 0 here. This is 90, and then this is 180. So at 45 degrees, it will be a value that is less than 1. At 45, you'll have this value somewhere. And at 135, you would have this value somewhere. So both of them are between -1 and 1. You can calculate those values. You can see what those values are. You can say, let's figure out cos of 45, input theta equal to 45, and that See what that value is. Just put this on a calculator. Cos 45. What does that give us? Under root 2 over 2. In decimals, that is 0.707. Evaluate cos 135 and see what that is. That's negative 0.707. What that tells us is, you can see that in the graph as well, both of these values, they are between negative 1 and 1, right? So cos theta, the value for cos theta is between negative 0.707 and positive 0.707. That tells us that they are between negative 1 and 1. So sum to infinity exists. It's a convergent sequence. So the sum to infinity, therefore, is going to exist in this case. All right. So now they're saying show that the sum to infinity can be written as cosecant theta plus cot theta. All right, let's figure out what the sum to infinity is. Sum to infinity is given by a over 1 minus r. What's the first term? The first term they said is sine theta over 1 minus r, that is 1 minus cos theta. Now that's a trigonometry problem. You have to convert it to this form that they wanted. Okay, sum to infinity, we need to write it like that somehow. Actually, let's try to work backwards because this is just one fraction. We need to break it down into multiple fractions, right? It'll become easier to understand if we try to do some reverse working from there to try to understand how we can convert it to that form. Let's try to do that reverse working. Cosecant theta, I could write that as 1 over sine theta. Cot theta, I could write as cos theta over sine theta. Okay, so if I have sine theta in the denominator, I could say in the numerator, I get sine theta. So this is just 1 plus cos theta in the numerator. Okay, 1 plus cos theta. In the denominator, I have sine theta. Okay, so we have 1 plus cos theta in the numerator. This is 1 minus cos theta. Okay, so what I can think of from here is we can use a trick like this. We can use a trick like this. Since we know that in order to get that, we need 1 plus cos theta in the numerator. What I can do here is I can say, let's multiply and divide this fraction by 1 plus cos theta. I can do that, right? I can multiply and divide by the same thing. So I can multiply by 1 plus cos theta and also divide by 1 plus cos theta. Now, when I do that, what happens is in the numerator, I get sine theta into 1 plus cos theta. In the denominator, this is a minus b into a plus b, and that's a square minus b square, so that's 1 minus cos square theta. Now, that becomes sine theta into 1 plus cos theta. In the denominator, I can write 1 minus cos square theta as sine square theta because I want to make something like this, right? So this becomes sine square theta in the denominator. Now, sine square and sine, they get cancelled. And now I have 1 plus cos theta divided by sine theta. And now I can say I just have to reverse work here. It's not exactly rationalizing because that's when rationalizing is when you want to remove square roots from the denominator, but it's very similar to that. This reverse working is what gave me that idea that, okay, this is what I want to get eventually to be able to then go to this step and this step. So I wanted 1 plus cos theta in the numerator. So to get that, I just said, let's just multiply and divide this fraction by 1 plus cos theta. And that gives me this. Now let's break it down into two parts. I could say it's the same thing as 1 over sine theta plus cos theta over sine theta. 1 over sine theta is cosecant theta and cos over sine is cot theta. That is what we wanted to show there. Make sense? That's a bit tricky, a bit hard to think of, but that's one way of approaching this. Another idea could also be, yeah, I'm just thinking about it. Is there an alternative? Let me think about it. Ach, let's just copy this here. Let's just copy this here. Let's see if we can figure out an alternative. Keep the end in mind, okay? Keep the end in mind. That's very important for proving identities as well. Keep an eye on what you want at the end. Cosecant theta plus cot theta. Okay, that's what you want at the end, right? Cosecant plus cot. Achha. So is there anything else that I could do? I could say, let's say, sine, if I write that as reciprocal, I could write sine as, because I want cosecant at the end, right? I want cosecant at the end. So I could write sine as 1 over cosecant theta. Okay. In the denominator, then I have 1 minus cos theta, although that's going to bring cosecant in the denominator. That's not exactly what we want. We could multiply and divide by cos. That will introduce a tan there. Let's just follow through with this and see what we get. Acha, if I do it like this, I get 1 over cosecant theta into 1 minus cos theta. Now, this will give me 1 over cosecant theta minus cosecant theta into cos theta. And now this is cos over sine, so that can be written as cot then. So 1 over cosecant theta minus, this is cos over sine, right? Cos theta, cosecant is reciprocal of sine, so that's cos over sine. So I could write that as cot theta. And now we need to get to that, but here we can again use that same idea then. We want cosecant theta plus cot theta in the numerator. So at this point, I could say, let's just multiply by cosecant theta plus cot theta and also divide by cosecant theta plus cot theta. In the numerator, that gives me what I wanted. Cosecant theta plus cot theta. In the denominator, it becomes a square minus b squared again. So that's cosecant square theta minus cot square theta. And that we know is 1 because of that identity 1 plus cot squared theta. That is identical to cosecant square theta. So cosecant square theta minus cot square theta, that is identical to 1. So the denominator is going to become 1. We have cosecant theta plus cot theta divided by 1, and that gives us cosecant theta. This is an alternative, but it uses the same idea as well. So I'm not sure if this is any simpler, but that could be another way of doing this. But this trick is important that we did here, multiplication and division by 1 plus cos theta, because sometimes in more complicated problems, you do end up having to do this. Now, how would you know about it? Work backwards. Work backwards from the final results that you want, and that will give you an idea. From the final result, try to work backwards like this to get an idea, okay, this is what I wanted in the numerator, 1 plus cos theta. To bring that, you multiply and divide by that like this. Okay? Achha, let's move on. That was part 2 of this. That was part 2 of this. That's it. This was question number 9. Next, we've got 10 and 12. Two more questions before we end. Question number 10 and question number 12. Let's do those. Let me copy that here. Question number 10. Okay, question 10 and question 11. Sorry, 12. You copy the B part of this as well. But there are more parts. This is part A, part B. Part C. All right, chale, let's do this. Actually, now they're saying in this question, time is in seconds at time t equal to 0. P starts from the point with position vector minus 30j. Okay, so we know its initial position, the starting position. That's something that we know. It's traveling with speed 58 with in this direction. Find the position vector of P at time t. All right, so can we write down the velocity vector? Speed is 58. The direction is this. What I can do is I can say, let's find the magnitude of that direction vector. Let's see what that turns out to be. Square root of 20 squared plus 21 squared. What's the magnitude of the direction vector? Let's call this direction vector D. We are calculating the magnitude of D. 20 squared plus 21 squared, square root of that, that's 29. Magnitude is 29. Acha, I want to make the magnitude 58. 29 times 2 is 58. So what we can do is we can say the velocity vector for P therefore is going to be velocity vector for P, that will just be this vector multiplied by 2. So 2 into 20i plus 21j, and that is 40i plus 42j. That's the velocity vector for P. Okay? Alternatively, you could find the unit vector in this direction. And then you could multiply that by 58. That will also give you the same thing. Okay? All right, now once we've got that velocity vector, what about the position vector of P? OP, we can write that as the initial position, which is minus 30j plus 40i plus 42j times t. So after time t, at time t, this is the position vector of the point P. That's what we were looking for. That's the first part. Okay. Let's look at the next part now. Also at time t equal to 0. So the same time that P started from, we have another particle that starts from the point with position vector minus 10i plus 18j. Q travels with this speed now 75 meters per second at an angle alpha above the positive axis, x-axis, where tan alpha is 7 over 24. Find the position vector of Q at time t. Now, there are two ways of doing this. One way could be you could find the value of alpha from this and then find cos alpha and tan alpha. You could say the horizontal component for this will be 75 cos alpha and the vertical component would be 75 sine alpha. Okay. So 75 cos alpha would be this, 75 sine alpha would be this. That's one idea you can do that. Alternatively, you could do it in exact form, so you don't have any decimals involved. It's tan alpha. It's angle alpha above the positive x-axis. Let's think about what the direction would be. If this is the starting point, the direction is like this, above positive x-axis. So positive x-axis is this, right? This is above positive x-axis such that tan alpha is 7 over 24. Tan alpha is 7 over 24. Tan is defined as perpendicular over the base, right? So if perpendicular is 7, base is 24, can we find the hypotenuse of this triangle? 7 squared plus 24 squared, square root of that. Let's see what that turns out to be. That's 25. The hypotenuse, that turns out to be 25. Okay. 8 squared equals 7 squared plus 24 squared. The value for h is 25. That's the hypotenuse of this figure. Now, once we've got the hypotenuse, we could write down the value of sine alpha and cos alpha. Because sine alpha is just opposite over hypotenuse. So that will be 7 over 25. We've got exact value for that. Cos alpha will be base over hypotenuse. That's 24 over 25. So we've got the values of sine alpha and cos alpha. Okay. You could also think of as the direction vector being, since this is perpendicular, this is horizontal, base, you could say direction vector is 24i plus 7j. You could also do it like that. That will also work. This will be the direction vector. 24i plus 7j. That will be the direction vector because 24 is horizontal, 7 is vertical. And then you could find the magnitude of this. That's 25. Multiply this by 3. That will give you 75. So the vector would turn out to be 72i plus 21j. That will work. That's also fine if you can do it like that. Alternatively, like I'm doing here, you could say now the velocity vector of q, what is that going to be? We could say magnitude is 75. So horizontal x component, that will be 75 cos alpha, vertical component 75 sine alpha. You can write it like this directly as well, which turns out to be 75 into cos alpha, which is 75 into 24 over 25, and 75 into 7 over 25. And that simplifies to 3 into 20, 3 into 24, which is 72, 75, 3 into 7, which is 21. In IJ form, you could say that is 72i plus 21j. So both ways would work. Direction vector method would also work. This would also work. You can do in using either of the two ways. Now, once we've got the velocity vector, what about the position vector of Q? Initial position was this. That's where it started from. Minus 10i plus 8j plus, sorry, that was 18j, minus 10i plus 18j plus 72i plus 21j times t. That is the position vector of q at time t. That is what we were looking for in the second part. ठीक है? Makes sense, right? Let's move on to the next one now. Part C. Determine whether they collide, you equate them and find the two possible values of t. See what you get from them. Let me do that. What I'll do is I'll write them in column vector form. That is easier to work with in problems like these. OP vector. What's OP vector? OP vector is minus 30j. So I component is 0. This is minus 30 plus the velocity vector 40 and 42. 40, 42 times t. Okay, that should equal OQ, which is minus 10, 18 plus 72 and 21 times t. Let's simplify both sides. On the left side, we get 40t and minus 30 plus 42t. On the right side, we get minus 10 plus 72t and 18 plus 21t. We get two equations from this. One equation is 40t equal to minus 10 plus 72t, and the other equation is minus 30 plus 42t equals 18 plus 21 times t. The first equation gives me 32t equal to 10. The value for t turns out to be 10 over 32, which is 5 over 16. The other one, that gives me 21t equal to 48, and t turns out to be 48 over 21, which is clearly not the same. 16 over 7. They're different values of t, right? They're different values of t. So that means they do not collide. ठीक है? There are different values of t. If we had gotten the same value of t, that would have told us that at the same value of t at the same time instant, their position vector is the same. Therefore, they collide. But in this case, we don't have any such time value at which their position vectors are the same. These are different time values at which they become equal. So that means they don't collide. Different values of t that we're getting, that means P and Q do not collide. You have to write down the conclusion that they do not collide. This is important, otherwise you lose 1 mark. So find the values of t and then write down that final conclusion from that as well. Okay, that's the final part. That's what we were supposed to find in this. That's question number 10. Chale, let's do one last question from this paper. And that is question number 12 that you guys asked about. Let's do that. Question number 12. All right, question 12. Let's do this. Okay, chale. Let's do these two questions now. These two parts now. Last question for today. The function f is defined by f of x equal to this. For x between negative 0.3 and plus 0.5, where x is in radians, solve this equation first of all. F of x equal to 0, what will that equation be? 15 cos squared into, I'll use a substitution right away so we have less stuff to write. Let's say a equals 3x plus 1.5. The angle is something other than x or theta, right? We substitute that with another letter. So let's say let a equals this. Change the interval as well now. It's negative 0.3. Input that here. 3 into negative 0.3 plus 1.5. That gives me 0.6. So A should be between 0.6 and 3 into 0.5 plus 1.5. That's 3. So A has to be between these two values. That's the interval for A. Okay. Now let's write down that equation. That equation becomes 15 cos square A plus 7 sine A minus 13 equal to 0. This is the equation that we now need to solve. How do we solve this equation now? We have cos squared and we have sine. Can we convert everything to one function? Cos squared can be written as 1 minus sine squared, so it becomes 15 into 1 minus sine square A plus 7 sine A minus 13, that equals 0. Simplify this and that will give you 15 minus 15 sine square A plus 7 sine A minus 13 equal to 0. That simplifies further to minus 15 sine square A plus 7 sine A plus 2 equal to 0. Multiply by negative, so the square term is positive. That just simplifies things a little. Now this is a quadratic equation. Can we factorize this? It looks like we can. I'll write sine as s. So 15s squared minus 7s minus 2 equals 0. That's the quadratic equation. We can factorize this as 15s squared minus 10s plus 3s minus 2 equal to 0. We get two factors from this. One factor is going to be 5s plus 1, and the other factor is 3s minus 2. And we get two possible values of s from this. S equals minus 1 over 5 or s equals 2 over 3. What does S represent? S represents sine A. So sine A is equal to negative 1 over 5, or sine A is equal to 2 over 3. These are the two possible values of sine that we get. What do we do now? We can find the basic angle. Sine alpha is equal to 1 over 5, or sine alpha is equal to 2 over 3. What's the interval that we've got for A? A is between 0.6 and 3. Let's find the basic angle for both of them. Sine inverse of 1 over 5. Angle is supposed to be in radians, right? Make sure your calculator mode is in radians. Sine inverse of 1 over 5, which is 0.2, and that gives me 0.20136. The other basic angle, 2 over 3, that is 0.7297. Okay, now these are two basic angles that we are getting. In the first case, sine is negative, so that means we are supposed to be in the third or fourth quadrants. In the second case, sine is positive, so we are supposed to be in the first or second quadrants. So now in the third or fourth quadrants, if we have alpha here or here, let's see what values we can find in that interval for A. There's no negative value, right? So we can only go in the positive direction. So go in the positive direction. This is the first angle that we're getting. This is the first angle that we're getting. What do we get? This is going to be A equal to pi plus 0.20136. Now this is going to go beyond that interval, right? Let me check that. 0.5, we input that here. That is 3 into 1.5. Yeah, so 1.5 plus 1.5, that's 3. It's greater than 3. So it is going outside the interval. So you can see the first case, that is not going to give you any values in the interval. The first case is not going to give you any values in the interval. So you can try that pi plus 0.20136, that's going outside the interval. You can evaluate that. Let's just do that for you. Pi plus 0.20136. This is bigger than bigger than 3. So we cannot consider this. This is not possible. This is outside interval. Now, if this is outside interval, the value in the fourth quadrant obviously is going to be outside the interval as well. So we can't consider that as well. From the other one now, we can get one angle in the first quadrant and another in the second quadrant. In the first quadrant, we can say A is equal to 0.7297. In the second quadrant, we can say that's pi minus 0.7297. Put that substitution back now. A was equal to 3x plus 1.5. Let's put that back. 3x plus 1.5, that is equal to 0.7297, or 3x plus 1.5, that is equal to pi minus 0.7297. Let's figure out the values of x that we get from this. From the first one, we get 0.7297 minus 1.5 divided by 3. And that's giving me negative 0.25677. To three significant figures, that will become negative 0.257. The other one, that gives me 0.30396, which rounds off to 0.304, to three significant figures. And this is the other possible answer that we're getting. These are the two solutions that we get at the end. X equals negative 0.257 and 0.304. And you can see they will automatically fall in that original interval when we follow the process correctly. And that's your final answer. Okay? Okay, there's Azan going on here. We'll have a 1 minute break and then resume. All right, chale. Let's do the second part now. Let's do the second part. And with that, we end this paper, inshallah, and this live session as well. Let's do this last question now. Find the x coordinates of the two stationary points on the curve y equals f of x. Okay, now what's the function? Y equals f of x. Okay, that's the function. Let me copy that here. Y equals 15 cos squared cos squared 3x plus 1.5. Me and Sir Saad are friends. Well, we know each other and we occasionally talk as well. We've met, I think, a couple of times as well when he came to Lahore. He's mashallah a really nice person. Mashallah. And a very good teacher as well, of course. I doesn't need me to say that, but still. 7 sine of 3x plus 1.5. Okay. 7 sine of 3x plus 1.5. Minus 30. Okay. Acha. This is what we're getting. The function that we have here. Okay. We want to find the x coordinates of the two stationary points on this curve. How do we do that? Let's find the derivative, dy over dx. What's the derivative of this going to be? It's a power function, right? It's a power function. Let's write it in proper form. First of all, we can say y equals 15 into cos of 3x plus 1.5 whole squared. That's what the actual function looks like, right? That's what the actual function looks like. Plus 7 sine of 3x plus 1.5 minus 13. Okay. Now, how do we differentiate this? How do we differentiate this? We find the derivative by applying the power rule on this. 15 is a number that's multiplying. So 15 remains as it is. We multiply by the power, so it becomes 15 times 2. Subtract 1 from the power, so it becomes cos of 3x plus 1.5 and multiplied by the derivative of what is inside the power, the base. What's the derivative of cos of 3x plus 1.5? Derivative of cos is minus sign, so it becomes minus sine of 3x plus 1.5. But then you also have to multiply it by the derivative of 3x plus 1.5, which is 3. That's the differentiation of this first term. Okay? Make sense? You have to be careful with this. You have to make sure that you are doing every single step in this. Now, the next term, what's the derivative of that going to be? Derivative of sine is cos, so it becomes 7 cos of 3x plus 1.5 multiplied by the derivative of 3x plus 1.5, which is 3. This is a constant, derivative of a constant is 0, so that remains, and we can just skip that as well. I'll just check my equation again, just in case. 15 cos squared, 15 cos squared, 3x plus 1.5, because I often make this careless error that I copy something wrong from the previous page. 7 sine of 3x plus 1.5 minus 13. Okay, looks fine. Then I wrote that as whole power. I multiplied by the power, subtracted 1 from the power, multiplied by the derivative of cos, which is minus sine. Okay, that's good. That looks okay. We have to figure out the stationary point. So we put this equal to 0 now. Put this equal to 0. That's how we find the derivative. That's how we find stationary points. Now on the right side, we've got 30 here, and then this 3 as well, and this negative sign as well. And that is going to become negative 90. Negative 90 into cos of 3x plus 1.5 into sine of 3x plus 1.5 plus 7 into 3, that is 21. 21 into cos of 3x plus 1.5. Okay? Now, cos of 3x plus 1.5 is common in both of them. Have we done something similar on the previous part? Actually, we did that for the original function, not for the derivative. Okay. Now we can take cos common. We can take cos common. Cos of 3x plus 1.5. If we take that common, that leaves us with minus 90 into sine of 3x plus 1.5 plus 21. This equals 0. Now, either cos of 3x plus 1.5 equals 0 and minus 90 into sine of 3x plus 1.5 plus 21, that is equal to 0. These are two equations that we get now. Solve both of them separately and that will give you the possible values of x. Now, just give me a second. I need to connect my charger, otherwise it's going to turn off in a minute. Okay, all right. Achha, so this is what we're getting now. Now, what was the interval that we had for x? Interval for x was this. We can do the same substitution that we did in the first part as well. Let a equals this, and that will change the interval the same way as well. The interval for a is going to be from 0.6 to 3. Let's do the substitution in both of those equations. Now, what do we get from that? The first equation, that gives us cos of a equal to 0. Now, when is cos 0? Cos is 0 at pi over 2. And on the positive side, it's 0 at pi over 2 and then 3 pi over 2. If you think about the graph of the cos function, right? 3 pi over 2 is going to be outside this interval. Pi over 2, however, is in this interval. So this gives us one possible solution, which is pi over 2. Okay, put that substitution back. 3x plus 1.5, that is equal to pi over 2. And that will give you one possible value for x. Let's figure this out. Pi over 2 minus 1.5 divided by 3. Okay, that's giving me, they don't want exact answers, right? Yeah. 0.02359 to three significant figures, that will become 0.0236. That is one possible value of x that we get. Okay. Acha, now what about the other equation? The other equation is minus 90 into sine of A plus 21, that equals 0. Sine A turns out to be 21 over 90, which is 7 over 30. Now for this, let's find the basic angle. Sine alpha equals 7 over 30. What's the basic angle that we get? Sine inverse of, make sure calculator is in radian mode, 7 over 30, and that gives me 0.2355. That's the basic angle that I'm getting. Think of quadrants now. This is sine. Sine is positive. Sine is positive in the first quadrant or the second quadrant. So we can either have the basic angle here or we can have the basic angle here. In the first quadrant, however, in the first quadrant, this value is not in the interval. This value is not in the interval. It's less than 0.6, right? And in the second quadrant, however, we do get a value in the interval, which will be this value. So that does fall in the interval. So we can say A is equal to pi minus 0.2355. That gives us a value for A. Put that substitution back, and you see what you get from that. 3x plus 1.5, that is equal to pi minus 0.2355. You can see what we get from this. Pi minus 0.2355 minus 1.5 divided by 3. And that's giving me 0.4687 to three significant figures, which will be 0.469. That's the other possible value of x that we're getting. If we go further and complete one full circle, come back here, that is obviously going to be outside that interval. So these are the two possible values of x that we get at which we have the stationary point for that function. Okay. Makes sense to everyone. That's our final answer. This is what we were looking for. And that completes the difficult questions from this third paper as well. I hope you find that helpful. This is all for today. This is it for today. Tomorrow and the day after tomorrow, inshallah, which means Sunday and on Monday, inshallah, we will be doing general Q&A sessions in which you can bring your questions, any problems that you have from any other papers that we have not yet done, and we will discuss them, inshallah. Just a reminder, you have a lot of other helpful content available on the channel. Look at the description below. You'll find revision videos that a lot of students find extremely helpful before their exams. You can have a look at that. Also, difficult questions from many of the recent papers. You'll find that playlist in the description below as well. I'll see you in the next class, inshallah. Allah Hafiz.